That's the next example. Example 2. Find the discharge for the water at the 20 degrees Celsius with the following pi data and reservoir elevation. So we have the three reservoirs. Okay, the reservoir number 1 is elevation of water is 30. Number 2 is 80. The number 3 is 9. Okay, and this is for the length of the Q1, L2 and L3. Okay, and this is diameter, and so we can estimate roughness, relative roughness for pi 1, pi 2, and pi 3. Okay, so the next step, we assume that the hydraulic line at junction is 23. Now we assume that is 23 at junction. Okay, so we expect that the flow should be like this: Q1 to junction and flowing to Q, because of hydraulic junction is greater than the elevation of the Q reservoir 2, so it should be the Q1 is equal to Q2 plus Q3. Okay, and next we use the Darcy-Weisbach equation for the pi number 1, 7 meter from the difference between 30 and 27, and assume that we have to assume the complete turbulent flow, so we can estimate the friction factor. In this case, it means F. Friction factor is a function of the roughness only, so we can estimate our F1, our F from this assumption, F1, F2, F3. Okay, given the relative roughness, we can estimate F1, F2, F3 from multi-diagram. Okay, and from F1 we can find what is the Q, what is the velocity. We can estimate velocity. Okay, and we can estimate Q because we know diameter. And then the next we use the different head between 23 and 18, 5 meter, and we can estimate V2 and Q2 about 0.278, and for the pi number 3 we can estimate Q3. But once we check the balance between the junction, we found that for the inflow is 1.38, but outflow is 1.09. So it means inflow is greater than outflow. So this one from so we say that the inflow is greater than outflow, and the Q is about 0.29. That is mean we assume that the elevation of junction is too low. Okay, too low, make a lot of inflow. We have to move a little bit higher at the elevation of junction, so we increase from 23 to 24.6 something like that. Okay, and do again for using the same equation for the different head and for the new Q 1.2 different head, and Q2 is 0.32 and Q3 is 0.856. Now we check again. We found that is delta Q is very close, but still inflow greater than outflow. Okay, inflow greater than outflow. Next we we can try more than this, but we can use extrapolation linearly to find that assume we have 2 points. The first we know that delta Q is this point, and this is elevation, and the next point we know that delta Q is 0.029 and this elevation. Okay, so when we can assume that it is a linear relationship, so we can plot the curve and extrapolate data to get the this point that hydraulic line junction should be 24.8. Okay. We do again, so we can find that the final Q is should be Q1, Q2 and Q3. Okay, do again at final step. And now is its balance between inflow and outflow.